Hello, welcome back. In this video, I'll show you how to draw SN1 mechanisms step by step and get them right every time. This question is asking us to show the mechanism for this reaction. Now, whenever we're drawing mechanism, you first of all need to determine what kind of mechanism your reaction will go through. We know that this is secondary alkyl halide and methanol is a weak nucleophile that is also a weak base. Essentially, we know that the mechanism for this reaction is SN1 and E1. However, the question only presented us with SN1 product and no E1 product. And so a mechanism should account only for the product that we're given. So let's go ahead and draw the mechanism. Now, since this is an SN1 mechanism, the first step is that the leaving group will leave. And when it does, it will form a carbocation intermediate. And then we'll have the leaving group here. However, carbocation intermediate has a trigonal planar geometry. In other words, the geometry of carbocation intermediate is such that it is flat. And because it is flat, the nucleophile can attack from either the top face or the bottom face. So a nucleophile is alcohol, specifically methanol. So that nucleophile can attack from the top face. If it attacks from the top face, we will place that nucleophile on a wedge bond. And if it attacks from the opposite side, from the bottom face, we will place the nucleophile on a dash bond. So because this nucleophile attacks or approaches the carbocation intermediate from the top face, we'll place it on a wedge bond. And since it's the oxygen that attacks that carbon, the oxygen is what we will draw next to that carbon. And that oxygen is connected to CH3 and hydrogen. And because of this reason, since the oxygen donates electron to the carbocation, we'll give that oxygen a positive charge. And since that oxygen is a positive, since we have oxonium ion, the anion will be attracted to the oxonium ion. Remember, you must always account for the charges at every step of the mechanism. Now, the next thing will be to get rid of the positive charge on that oxonium ion. To do that, we will then use the solvent. So the solvent also is methanol. So the methanol solvent will be acting as a base in this case. So this third step is deprotonation. It's an acid-base reaction in which the base will grab the proton, the bond here will break, and the excess electron will go to the oxygen, thereby neutralizing the positive charge on that oxygen. And eventually we would have a product. And when the base grabs that proton, it will form the conjugate acid. So we'll have this oxonium ion. Again, the anion will be attracted towards the oxonium ion. And this will be the mechanism for how this particular product is formed. So normally, if the stereochemistry here is the stereochemistry here is R, and this is R, and this is S. So this is telling us that in an SN1 mechanism, you will always have racemic mixture, a mixture of both or opposite chiral center. Racemic mixture. So let's go ahead and draw the mechanism for the other product. Again, the Cl will leave first. When that happens, you will form the carbocation intermediate. Carbocation has a geometry of trigonal planar, and trigonal planar means flat. Trigonal planar means flat. So once the carbocation intermediate is formed, the methanol nucleophile, which is the weak nucleophile, can also attack the carbocation intermediate from the opposite side. And it could do this attack because the carbocation intermediate is flat. When it does that, we will place that nucleophile on a dash bond. And we'll give that oxygen a positive charge. And with methanol, we can now use the solvent to deprotonate the oxonium ion, the intermediate product. Don't forget to draw your Cl minus here. So when this happens, we will have this other product. Then we'll have these intermediates to our byproduct. Of course, this will eventually lead to the formation of HCl and methanol. You can show that if you want, but you don't have to. If you found this video helpful, please like and subscribe to my channel. Also, feel free to share the link with someone who might need it. Thanks for watching, and I'll see you in the next video. Bye.